In this episode, we'll explore one of the most essential parts of any RF design: frequency bands and channel bandwidth. You will see how 3GPP divides the 5G spectrum into FR1 and FR2, and how new radio achieves incredible flexibility in bandwidth and deployment. Every wireless system starts with spectrum, and in 5G new radio, that spectrum is more dynamic than ever. 3GPP defines bands by uplink and downlink frequency ranges, duplex mode, and channel bandwidth capability. Each band gets a simple numeric name like N78, N41, or N258. And all these are standardized in 3GPP TS38.101 for user equipment and 38.104 for base stations. 3GPP separates all 5G bands into two major frequency ranges: FR1 sub-6 GHz, covering roughly 410 MHz to 7.125 GHz, and FR2, the millimeter wave, spanning 24.25 GHz to 71 GHz. Each range comes with unique physical and RF design challenges. FR1 provides wider coverage, better penetration, and compatibility with LTE infrastructure. FR2 offers massive contiguous bandwidth, perfect for multi-gigabit data rates, but suffers higher path loss and requires beamforming for stable links. Another major difference between LTE and the new radio lies in channel bandwidth flexibility. LTE was limited to 20 MHz per carrier. New radio can scale up to 100 MHz in FR1 and 400 MHz in FR2 per carrier. Multiple carriers can then be aggregated for even larger bandwidth. New radio also introduces variable sub-carrier spacing called numerology, the mu. For example, mu equal to 0, then the sub-carrier spacing is 15 kHz, like the LTE. Mu equal to 1, then the sub-carrier spacing is 30 kHz. And if mu equal to 3, then the sub-carrier spacing is 120 kHz, which is used in FR2. This allows new radio to adapt efficiently across frequencies, latency targets, and deployment types. One of the most elegant new radio innovations is the bandwidth part, or BWP. Instead of forcing a UE to process the entire wideband channel, new radio allows a UE to operate within one or more bandwidth paths, essentially slices of the carrier bandwidth. This reduces power consumption and enables flexible resource allocation for users with different needs, like IoT devices versus enhanced mobile broadband users. Modern smartphones can combine multiple bands using carrier aggregation or dual connectivity. Common examples include N78 plus N41 for middle band aggregation, N78 plus LTE-B3 for long standalone operation, N258 plus N260 for millimeter wave extension. These combinations are listed in 3GPP tables and validated through certification testing. So that's the backbone of the 5G spectrum story FR1, FR2 bandwidths and bandwidth paths. Together, they make new radio incredibly flexible, scalable, and future-proof. In the next episode, we'll look at how carrier aggregation and dual connectivity push these concepts even further. Thanks for watching, and then don't forget to subscribe for more RF tips and insights. Thank you.